podcast is all about esterification reactions, which by the name you have probably gathered form esters. All right, so esterification is the formation of an ester, and we're going to form an ester by starting with a carboxylic acid and an alcohol. This does require an acid catalyst and heat, which you are seeing right there over my double-headed arrows because it is an equilibrium reaction. Okay, so we're going to start with a carboxylic acid. Here we have ethanoic acid, and I love practicing naming because this is just extra stuff that's going to help me for a quiz or a test. And that's reacting with the alcohol ethanol. That's the drinking kind of alcohol. And I could also put the common names on there, but let's focus on the reaction. All right, so in the esterification reaction, we are going to remove the hydroxyl group from the carboxylic acid, and that is going to react with the hydrogen on the alcohol. Okay, so as you may have guessed, this is going to form water. Okay, so water is a side product. The alcohol has lost its hydrogen, so this portion right here, starting with the oxygen, is going to attach to the carbon with the carbonyl. So here is what was my alcohol, and here is what was my carboxylic acid. Okay, so those are going to come together and they will form an ester bond. All right, so let's practice from a word equation, and something to keep in mind is we have not learned how to name esters yet, but it would be good practice once we do learn how to name esters to come back and name all of these just for the extra practice. Okay, butanoic acid and ethanol react in the presence of acid and heat. All right, so let's draw our butanoic acid. That's a 4-carbon carboxylic acid. And I'm going to use different colors because the colors really help me to see what's going on and where things are coming from. Okay, so we have an acid catalyst. They didn't tell me what acid I'm using, so I'm going to use that generic sign for acid, the H+, and then a delta for heat. And ethanol, CH3, CH2OH. Okay, we're ready to start. So I will remove the OH from the carboxylic acid, and I will remove the hydrogen from my alcohol, and this is going to form my side product, which is water. Okay, and I'm just going to write as HOH. Obviously this is H2O, you can write as H2O, but again I just like to show the colors of where these are coming from. And we are going to form an ester, which means we're going to take this portion of the alcohol, we're going to flip it around, and the oxygen portion is going to bond to the carbonyl carbon. CH2. Okay, so this was originally the carboxylic acid, and then here is the alcohol portion. I'm writing really small. Whew. That scared the crap out of me. No idea what that was. All right, so one application, a very strange application of esterification, is in the formation of bladylquinone, which is a sex pheromone for the female German cockroach. Okay, so here we see we start with a carboxylic acid and an alcohol, and it goes through an esterification reaction in the presence of sulfuric acid, and we form this sex pheromone. This is actually pretty genius because we can use the sex pheromone that female cockroaches use to communicate with male cockroaches. We can bait a trap with this pheromone, and it's going to bring all the male cockroaches in, and it's going to kill them. So it can be used in controlling the cockroach population. A little bait and switch there.